Hello everyone, welcome to Learn Overflow. In this video, we will discuss about another LeetCode problem, construct array, target array with multiple sums. This is an hard level problem. We'll look into how easily we can solve this problem. So the question says, we are given an array target of n integers. So this target has n integer. There we have a target over here. And also it says that from starting array, ARR, consisting of n ones. Okay, so we need to do something with this ARR. Need to find out further what it says. You may perform the following procedures. Okay, so it says like we have like an ARR array that contains n elements of ones. So all the elements in our ARR array will contain one. Okay, how many n being the number of n integers we have in our target. Okay, so then it says that let x be the sum of all the elements currently in our array. Okay, currently in our array being the ARR array. So we need to perform the following procedure on the ARR array. Okay, remember that. So x be the sum of all elements. So initially, what will be the sum? Sum will be n. If like consisting of n ones, then the sum will be n. So let's read further. It says like x be the sum of all elements currently in the array. Okay, so choose an index I. We need to choose an index that is from 0 less than equal to I less than equal to 1. So I within the range of the array, and set the value of ARR at index 1 like index I to x. So we need to change this particular ARR value from I to the particular x value. Okay, now well, it says like you need to repeat this procedure as many times as needed. Okay, so we can keep on repeating this step as many times as possible. Okay, so then it says return true if it is possible to construct the target array from error, otherwise return false. Okay, so it just wanna know whether we can construct an array or not. So look here, there's something you need to understand. It doesn't say to return you the constructed array. So it doesn't say to return you the exact array being constructed from here. It rather says whether we can construct an array or not. Like whether it is possible to construct an array of error or like of target array or not. So think carefully. There can be multiple loopholes when they don't ask for the exact array. They are asking for the whether it is possible or not. Okay, so let's see an example. I will like come to this point after looking at the examples. Okay, what I was trying to say, I'll be back with that. So it says we are given an array of 9, 3 and 5. It says like start with an array ARR of 111 we have over here, and it says like the sum, the 111 is obviously 3, so we choose an index of 1 and replace that with our 3. Okay, and then the sum becomes 5. Then we choose an index of 2 and then replace that with 5 over here. And then the sum becomes 9. We choose an index 0 and replace that with 9. So thus it becomes like 935. But think carefully. Okay, think carefully. This is exactly what we're trying to do, to just constructing the exact array. But think carefully, is it really necessary to do the choosing of the particular index? What I'm trying to say is like, say you have an array, of like 1, 1 and 1, that's the error we have. We find its sum to be 3. We replace it something like 3, like 3 and then 1 and 1. Okay, we do something like that. Then we find that 3 plus 1 plus 1 is 5. So we do something like 3 plus 5 plus like 1. So we find that 3 plus 5 plus 1 is 9. So we simply do something like 3 plus 5 plus, then it becomes 9. So we replace that one. Now the thing is it an array that we are able to construct from, like we are able to construct? This can be an array that we are able to construct. So when it says like we need to choose an index I, so that's what makes the question typical. But remember, at the end, we are required to return a true or false, whether we can construct the array or not. Simply look at this array that we can construct by following the steps. In this particular array, what happens? We are able to get the particular numbers we have over here. Okay, so 9, 3 and 5. We have those numbers 9, 3 and 5, but not in the same arrangement. We need to do a different arrangement for that. But does it actually matter to us? We are finding that we got 9, we got 5, and we got 3 for our answer, right? And those are the 3 elements we need to find in our target element. Like the target element has those. And we need to return. Yes, we can figure out, like that's what we are trying to return, that yes, we can construct this array because we got these 3 values that are within our target element, right? So that was the main constraint. The constraint is not that you need to choose, okay? If you try to choose and build the array, like you are not asked to build this array, you are asked to check whether it is possible or not. So that was the small trick within this question, you can say. Let's look at the second example, you will understand further. In the second example, it's like 1, 1, 1, and 2. It says it's false because it's not possible. So what was that? It was like 1, 1, 1, and 2, right? So we are supposed to reach at this position. And we find that if there are like 4 elements in the array, right, then it is no way possible that we can reach a sum of 2. Is it possible? Because like we are supposed to take the sum of all the elements. So we are sure that if we have a sum of 2 in our array and the total target array length is something greater than the sum, then like the particular, like the largest element is like lesser than the like the target length, then it's not possible to construct the array, right? Thus we can simply say false. We are not bothered whether we can go ahead or not and what else, right? So think of this exactly. We are not bothered to construct this array, to construct this particular array for us. We are rather bothered to check whether the elements that we have in our array can be found out or not. Like we can reach those numbers or not in our particular array, like in the array. So think of this particular question in the reverse order. So it's like it will be a tremendous task to construct an like array from this 111, right? So think of the why I'm saying so. Say you have a target of like something bigger number, okay? Something like huge number over here, and then you have a value of like 1, okay? So if you have a target like this, then how many times you will go on continuing and you will find out that you cannot reach and something like that, right? That may be a problematic for us, like that may go into a time limit exception if we just want to construct an array from here, okay? So in the reverse case, what we can do, we can start from our target array and then find the maximum element we have in our target array, okay? So maximum element we have in our target array is like 9, okay? Then we do the rest is like find the sum of the other 2, okay? And then like we find that sum of the other 2 is like 8. So if we subtract this from 8, can we reach to something like 1? So the main target was like this, okay? So it's like we only have this much element, so we are going to like simply subtract, but rather we will go ahead with something called a modulo. Like why modulo? Because numbers can be this big, okay? So that was the condition. So like for a single element, we just as a on the example 1, I just said like we can subtract this and we find that we can reach an number of 1. If we reach a number of 1, we'll go ahead like subtract that number of 1, like we make it as 1, okay? Then we reach at this position exactly. Then next we find the next largest element in the array. So the next largest element in the array is like 5. And then from that we subtract what? We subtract the other 2 elements, that is 3 plus 1, 4. So 3 plus 1 is 4, okay? So we find that, and we find it's again we're reaching to 1. Rather, without subtracting, we can rather say we are doing a modulo operation, that is a remainder operation. How is it so? We are finding out that if we divide 5 with this 4, then whether we can reach to 1 or not. So like much faster statement, because if we keep subtracting, we may end up like if it has a number like say 9 at over here also, like without this 5, if we had 9 over here also, then what would have happened? We have done something like 9 plus like 9 minus 4 is like more or less we will end up like 5, and again we will have a larger value. Then we'll do like 5 minus 4 is then like 1. So rather we will go ahead with a modulo operation to just find out all the like all the times we need to subtract the particular value. So we found like again we reached this particular one, right? Now we next step is like finding out the maximum value we have in our particular array, and then like we find that 3, and we subtracted what the rest of the elements sum we have over here, right? So what is the rest of the elements sum? Is like 2, and we find out is again in 1. So if we find out that the final answer, like the final sum we have the final sum is what? Final sum is 1 plus 1 plus 1 is 3. And like the final check for us will be, if we find the all the numbers are like 1, like the maximum value in our target array is 1, right? So we'll go ahead and find the sum of the arrays, like all the elements, sum of all the elements. And what do we find out of here? We find that the sum is 3. Okay, so what will be our check? Look at the thing, like what will be the target dot length? Target dot length will be 3 elements, right? So we have 3 elements and target dot length will be 3 elements. So we'll check that whether the sum we have when, or like the maximum element in our array is 1, the sum we have is equals to the target length, like a length of target. So that would be exactly similar equal, because like every element is 1 with us, right? So that's what we are trying to find. If that is so, then we are sure, like we are confirmed that yes, we can reach the element and return a true for that case. So that's more or less the idea behind this whole question. This is not the question that you will choose an index and do something like that. Rather, you will find an solution. Rather, you will find that exact point to hit. It's not the finding the exact number or constructing that array. Rather, it's finding out whether we can reach or not. Like it's simply whether we can reach or not. We are not interested to exactly construct the array. We are finding out if it is possible or not. Okay, so that was the question. I hope I can make you understand how this actually works. So here I took another example, if you remember. So how is it so? What we can do over here, we'll simply go ahead and take this huge number, okay, and then in this huge number we'll do like we are here like 1 0 0 0 0 0 0. Okay, there are 6 zeros. So we'll do modulo 1 is equals what? Is equals 0. So then our array becomes like 0 and 1. Okay, so that's what our array becomes. So this can be a corner case, remember. So 0 and 1. And then what happens over here, we'll find that the sum of all the elements is 1, but the length of the target element is how much? 2. So does it find? No, we cannot find, like we cannot reach an array from 1 1 to this particular array given to us, the target array. Okay, so that's the question behind this whole like that's the thinking behind this whole question. So there is another example. Let me just erase all this. So there is this another example, like example 3. Let's have a look at this. The example 3 is like 8 and 5, and we can find that if like there are 2 elements, 1 and 2, like 1 and 1, then we can reach somewhere called in the second step we can reach like 1 and 2, right? Then we have like 3, the sum is 3, then we can reach like 3 and 2, right? So 3 and 2, and then we have a sum of 5, then we can reach something like 3 and 5, right? So then we have a sum of 8, then we can reach somewhere like 8 and 5, right? So that is the example. So how will our particular concept that we discussed now, how will it work? It will work like we will divide 8 with 5. So what we are remained with, we are left with like 3 and 5. So that's what where we land. And then we divide 5 with like modulo 5 will be 3. So then we reach it to an array element, something like this. 3 and 2 will be there. Then we keep dividing like 3 modulo 2. This will end up having like 1 2 being our answer, and then we divide like 2 modulo 1, and we end up somewhere there. Then we check whether our particular array is same or not, like the length is equals to the sum we have remained with. The sum we remained with the 2, and the length is also 2. So we find out that's the condition we like. That's the way we can think on this question. Okay. Further, if you just look into this, we will find that you will find that there are like few constraints. The constraint is n equals to target length. So that's the given over here. So we are all the time it's like n n n. So it means that our target length. Okay, and then it also says that this n can be the number of elements in our array can be 5 into 10 to the power 4. Wait, that's a huge number. Okay, so when we find that we need to find a sum of this many elements, we shouldn't be like that much obvious that it will all end up being a sum of sum being in a integer value. It may end up in a long type value. Why I'm saying so? Like each of the element in our target can be up to 10 to the power 9. So say you are summing a total of 5 into 10 to the power 4 elements, with each element having a value of 10 to the power 9. that won't end up in a integer type value, right? So integer don't have that much capacity. So we need to make sure that we end up having like the sum being as a long type variable so that we can handle that situation over here, okay? So that can be a situation. And also remember that I said, like, if we, the main idea is we can go ahead with subtracting the value, but the subtracting may end up with a time limit exception. So we need to take care that we are not subtracting, rather we are finding the modulo operation, and that's how the modulo operation works. We end up finding all the subtractions done at a single time, and we'll find the final answer at the same time. So that's the modulo operation. That's how it works. Okay. So these are the two conditions that we need to keep in mind. Now, let's go ahead and type some code and find out how we can actually, like this exact concept can be done in a code, okay? So let's write. All right. So here we find that this particular question that we try to solve is like it's working. You can say it's like a 15 solution. Okay. Now let's try to understand how this question actually works or what we actually did in this particular question. Okay. The first thing we do over here is like took a variable sum. As I said, we will need to find out the exact sum we have over here, right? So we had like we had this exact 935, and that sum is 17. So what we are trying to do over here, okay? Now we took a priority queue. Why we took a priority queue? Like why a priority queue we need over here? The main idea is we were through the whole discussion we are doing something like we take out this maximum element and then find out the rest of the elements we have over in our array, and then try to find out whether it's possible or not to move ahead or not. Okay, so thus we at each point we have a note of what's the maximum in our array. So if to keep a track of that, we just need a priority queue for here. Okay, then we are doing the main part. What is that? We are going to for each of the elements we have in our target. Okay, then we're doing what? We are making a total sum, that is the sum of all the elements we have over here, and at the same time we are adding all our elements to our priority queue. Okay, so that's the thing we're doing. The main thing, like we added each of the elements. Now here is the exact thing that we're doing to keep a track, or rather to keep a like to find our exact solution. So what is it we are doing? We're checking if like the sum is greater than 1. So that means that basically means say there's an there can be a corner case, like say we have an array of only one element. Okay, we have an array of like only one element, and what will be the answer for this? If we have an array of only one element, is it a good idea to move into this array and then find out this whole like type of solution? If we have only one element, then that should be one, or like we cannot do other operation. The sum will be, we cannot do some subtraction, we can do some modulo operation on that, right? The sum is always one. So if the sum is one for us, so we simply need to check for the final condition whether the sum is equal to the target length or not. For one element, target length will be one, so our sum should be one. So that's the basic criteria to check. Okay, and also why we need a sum greater than one? That means if in case we have like two elements, say two or more element, and I'm saying like the minimum values can be one or one. So in that case, sum should be like greater than equals to two, right? Greater than or equals to two. That should be the sum. Or if the elements are two or more, the sum should be greater than equals to two. That's the minimum condition we have over it. But in case we have a lesser sum, then no point moving ahead into our condition, right? So that's the idea behind this sum greater than one. Now the next thing simply is we are checking the top like the peak of the element priority queue is greater than sum by 2. What does it exactly mean? Say we have like 9, 3, and 5 in our question. Okay, the sum is 17. Okay, so the sum we find is 17, and then the sum by 2 is more or less like it's an integer value. So like it will be taken as an integer, or if you take it as a long as well, so it doesn't matter. So the sum by 2 will be more or less 8, right? Rather you can say 8.5, but 8 because we are going with long values. We don't have a decimal for us. Now what is the maxif? Here maxif dot peak. Maxif dot peak is 9. So we're finding the 9 greater than 8. Exactly why we did this. Say take up an example like this. Okay, what happens? What is sum? Sum is 2 plus 1, 3 plus 4 plus 5. Okay, 5, and the max is 2. Okay, like we have this 2. That's the maxif dot peak, and then we find that our sum is 5 by 2. So 5 by 2 is that's 2, right? So 5 by 2 is 2, so that equals 5 by 2. So in that case, you know that this is already false. There's no like nothing moving ahead in this exactly, because like it should be greater than our particular value sum. So if it's equal to our value sum, we cannot move ahead with this. Like we can be sure that it will end up in a false condition, right? So that's the idea behind this, that it should be greater than the sum values, because we're summing all the values, and all the values being like considering our element being included within it, and the division is like, and the like half of the element sum is not greater than the it's not less than our peak value. So we cannot move ahead in this, right? I will add more into this when we're going to the last lines. Okay, I'll come over here. Now, what else we have over here? We find the maximum element being the peak of the, like the, we kind of store a max value as a int max peak. Okay, so thus we pull the, like take out the maximum value from our heap. Now we subtract it from our sum. So this was the thing you can think of, like if our sum don't contain more than like values more than the current max element, then when you subtract this, so that then sum and max will more or less become an equal value. And thus when we like do this kind of operation like max mod sum, and remember that's like 2, like in this condition 2, like max is 2 and sum is also like we find out the sum by 2 is also 2, so we end up finding 0. Okay, so that's what the condition is. So we simply stop over there and break it. So that's the condition to this time of like time complexity that you can think of. Then what we're doing over here, we just subtracted, like took out the sum from our max. So that means when you have 9, 3, and 5, what we did, we made our sum as like only 3 and 5. Okay, so sum is currently 8, and now our max is 9. That's being stored over here. Okay, sum is 8. Now we're checking if sum is less than 1. No, sum is not less than 1. That means sum is greater than 1. So if sum is less than or equal to 1, we need to check if sum is 0, then we should return false, else we can return true. So that's depending on the sum. Okay, so that was the condition we have. That's a by condition. We can think of this as a corner case. We'll come to this minutes later. Now what we're doing, we just added our like the max mod the sum we have, like sum is 8 and max mod 8 is like max was 9. So exactly what we are doing is 9 mod 8 is basically 1. We are adding 1 to our maxim, and then we are again adding this 1 to our final sum. So now our sum became 9, right? So that's how we are going ahead with that. So that should be our answer after removing the, like after 9, 3, 5. If we remove 9 and find out the value, then it should be 1, 3, and 5. That was the step we saw a few minutes back. So 1, 3, 5, and that should be our sum being the 9. So that was the condition we have over here. Okay. And finally, we'll keep on reducing it, and at the end, we'll reduce it to something like 1, 1, 1. And if we reduce it to something like 1, 1, 1, that means we now can check to like we are out of this value. So 1, 1, 1 is like the value is like 3. So we find that sum greater than 1, true. But maxim.peak, peak is 1. Okay, we find peak is 1 and it's not greater than sum by 2. Sum by 2 is it's like sum by 2 is a 3 and it's not greater than 3. So that's the breaking condition for us. Okay, that's what we are finding out over here. So we find that one is like break, and then after breaking, we just find this total, like whether the sum is equal to a target length or not. If it's equal to target length, we know it's true, as we know it false. But as I said, I didn't mention this question here. So here we were doing something like sum greater than 1 is the basic condition we have over there, right? But here we find the sum is less than equal to 1, right? So if sum is less than equal to 1, that basically means, see, if sum is less than equal to 1, that means what can be the values? Sum can be something like, say exactly, sum can be something like 0 or sum can be something like 1. Okay, so these two are the only conditions we can have over here. Okay, why not -1, -2? Because remember, sum is actually the sum of these 3 values, or 3, 4, how many values we have. So can we do like the, if we take the maximum value from here, right, that is, we have a sum of 70, and if we subtract the maximum value from here, can we come across a value that is in negative, like that is less than 0? No, we cannot come across, because these are the minimum elements we have over here. And for the elements like this, where we have only single element, we don't have such element in our like within our loop. Why is it so? We have like removed all them from here, right? So if we have removed all of those from the initial condition, so we don't have those kind of elements like corner cases within us. So we are sure that if from the total sum, if we subtract the maximum element, that cannot be negative, because we have more than one element, and the total sum, minimum total sum will be 2. right? And from the total sum, if we remove the maximum element, that will be one in any case, because we have the if we look here, we have the particular target, like this one will be the minimum value over here, right? So if that is so, we know that it's not possible, right? The target value is minimum one, so we know that that's not a possible case for us. So that's what we are thinking of, and that's what the whole question is all about. So I hope I can make you understand how this particular question is working, and how easily you can think on this kind of questions and find out an answer to this. So thank you all for watching this video. If you haven't subscribed to this channel yet, make sure you subscribe to this channel for more such regular LeetCode questions and problems being discussed. So thank you all. Hope to see you soon in my next video as well. Also, make sure you just like this video and comment down your any questions you have, like any kind of questions if you have, or if you didn't understand any part of it. I'll try to make you understand in the comments as well. So thank you all for watching this video.